Therefore, after simplification, the limit of this expression becomes this one. Now we see the numerator is in irrational form. Therefore, to calculate the limiting value, we have to rationalize this one. We proceed like x minus 2 from numerator and denominator. Finally, what we get? Now, the value is 4, therefore limiting value is 4. Given function gx is equal to this, we have to find the limit this one. We first calculate, already I have stated in the earlier problem, calculate this expression gx minus g1 by x minus 1. Now, gx minus g1 is equal to minus root over 16 minus x square minus if I put the value 1, it will be 16 minus 1, that is 15. Therefore, finally, what we get? This is plus. Therefore, limit x tends to 1, gx minus g1 by x minus 1 is equal to limit x tends to 1. Value of this one, numerator is this one, I write this here. Therefore, after simplification, the limit of this expression becomes this one. Now we see the numerator is in irrational form. Therefore, to calculate the limiting value, we have to rationalize this one. We proceed like this. This is equal to limit x tends to 1. Then limit x tends to 1. Numerator is 15 minus 16 minus x square. This is x minus 1 into root 15 plus root over 16 minus x square, and we simplify this one. What we get? X square minus 1. X square minus 1 means we can write that x plus 1 into x minus 1. Now we can cancel x minus 1. Since x is not equal to 1, we mention that here. Since x is not equal to 1. Now finally we put the value x equal to 1, and After simplification, we have got the value 1 by 15. This is the answer. I have taken another sum as earlier. First of all, I have calculated the numerator and got this value, then limiting value, and according to the process of finding limit, I have proceeded and got the value 1 by root 15. Now let me move to the, according to me, this is the vital part of learning limit or have the knowledge of limit. I have taken limit x tends to 2 of x plus 2, then limit x tends to 2 x square minus 4 divided by x minus 2. We shall explain this. First of all, I have taken fx equal to x plus 2, and already in earlier classes we have drawn the graph of y equal to x plus 2, that is why I have taken y that is equal to x plus 2 and constructed this table, and I have taken here two mutually perpendicular lines which are x-axis, the horizontal one is x-axis and the perpendicular one perpendicular to this x-axis is y-axis, already you have learned. Now I have plotted the points. First of all 0 2, then 1 3, then 2 4, then minus 1 1, then minus 2 0. Obtained from this, when x equal to 0, value of y is 2, when x equal to 1, value of y is 3, when x equal to 2, value of y will be 4, etc. And plotted those points according to specific scale used in drawing the graph. Then I have joined those points by straight line segment. Also I have extended the segment on both the sides, and this straight line indicates the graph of y equal to x plus 2. What we find, there is no break at all, and when x tends to 2, that means when x is near to 2, slightly less than 2 or slightly greater than 2, the value of x plus 2 will be approximately 4, and from the graph it is clear when x equal to 2, this is 2 4 point, this point is 2 4. Therefore from this graph also we can this is this is 2 0 point. The perpendicular I have drawn that intersects the graph at the point 2 4. Coordinates of that point will be 2 4. That is value of y or fx is 4, and we have considered points near to 2 which are before 2 0 and after 2 0, just before or less than 2, greater than 2. And if we draw perpendiculars, we shall see that values of these coordinates or lengths of these perpendiculars will be near to 4. That is why limiting value of x plus 2 as x tends to 2 will be 4. Thus we have explained with the help of graph limiting value of x plus 2 as x tends to 2 is equal to 0. Now we consider this one. If we simplify, it will be limit x tends to 2, x plus 2 into x minus 2, x minus 2. Now, since x tends to 2, here x is not equal to 2. Therefore, x minus 2 will not be 0. Then we can cancel x minus 2 from numerator and denominator. Finally, what we get? Now, the value is 4, therefore limiting value is 4. Now, in case of x equal to 2, what will happen? X equal to 2, that means x minus 2 will be 0. That means division by 0, that is undefined. If we draw the graph of this one, here at this point, we shall not get I have given open brackets here. That means there is no value, or value of x square minus 4 divided by x minus 2 does not exist. There is a break. From this, we can explain x square minus 4 by x minus 2 when x equal to 2 does not exist. From this graph, it is clear when x equal to 2, this does not exist. And if we draw the graph, there will be a break or gap at x equal to 2. Hence, it is explained geometrically the limiting value of x plus 2 as well as x square minus 4 divided by x minus 2 when x tends to 2. But for x equal to 2, there will be a gap. If we draw the graph, in that case, the graph will be like this. There is a clear gap in the straight line. Hence, it is explained.